dear learners, for this course on engineering graphics. In our module 5 we were discussing about isometric projection. Let us move on to solve our problem number 5 on isometric projection. Problem number 5 states that draw the isometric projection of frustum of square pyramid having sides measuring 50 mm and 30 mm with height 60 millimeters. Before moving on to solve this frustum of square pyramid, frustum of any solid is obtained when the cutting plane is parallel to the base. That is, if I consider a cone or a pyramid, if I rest a pyramid in the horizontal plane without inclining to any of the planes, front view, the pyramids will always look like a triangle. So therefore, this is a front view of a pyramid or a cone. Now, if the cutting plane is parallel to the base, so this is the base of the pyramid and this is the cutting plane. If I consider, let us say section XX is the cutting plane. If this cutting plane is parallel to the base, then the solid which is retained is termed as frustum. If the cutting plane is inclined at an angle to the base, that is, let us say I have a pyramid in the front view which is resting on horizontal plane without inclining to any of the planes. In the front view, I can see it as a triangle. If the cutting plane is inclined at an angle to the base, then the portion which is remaining is termed as truncated portion. If the cutting plane is parallel to the base, then the portion which is retained is termed as frustum. When the cutting plane is inclined at an angle of theta to the base, then the portion which is retained is termed as truncation. So this is the difference between frustum and truncation. Now he is asking us to draw the isometric projection of frustum of square pyramid. So before moving on to draw the isometric projection of frustum of square pyramid, let us draw the front view and top view when the square pyramid is resting on horizontal plane without inclining to any of the planes. If I do that, I will get a triangle in the front view and a square in the top view. So let us draw the front view and top view of the square pyramid for the given dimension. Drawing the front view and top view of the square pyramid when it is standing on horizontal plane without inclining to any of the planes. Outer side of the square pyramid in the top view is measuring 50 millimeters. Now construct a square of side 50 millimeters. Taking the projection, since it is a pyramid, identify the center and draw dark lines from all the corners to the center. Marking the axis of this pyramid, the height is given as 60 millimeters. So therefore, marking 60 mm height. Now the top side is stating the length of 30 millimeters. So therefore, mark 15 mm on either side of the axis. Now join the longer edges. Now again take the projection downwards. Construct another square of side length is equal to 30 millimeters. Show the dimensions. observe the cutting plane is parallel to the base. The base and the cutting plane are parallel. So this is the frustum of the square pyramid what is asked, with the outer side length measuring 50 mm and inner side length measuring 30 mm. Now in the top view, if I view this pyramid, I will see an hollow space. Therefore, erase this inner triangle faces. If I do that, I will get, this completes the required front view and top view of the frustum of the square pyramid what is asked. Now with the help of this, let us construct the isometric projection of this frustum of square pyramid. First, let us construct the base, that is square of side 50 mm cross 50 mm. So therefore, in an iso sheet, choosing a point, draw 5 boxes cross 5 boxes square. If I do that, the bottom face will look like choosing 2 lines on either side which are inclined 30 degrees in the iso sheet. Construct a square of side 50 millimeters using a very thin line. Drawing parallel lines this completes the base of this square pyramid whose side is 50 mm cross 50 mm. I have chosen 5 boxes cross 5 boxes on all the 4 sides, and I have constructed the isometric projection of square when the surface is horizontal. Now identify the center of the bottom face. Let us say it as center O1. Now we know the height of this frustum, which is 60 millimeters. So choose 6 boxes in the iso sheet and mark center O2. If I choose 6 boxes on the iso sheet, I will get center O2. Now taking this as center, construct the top face. The top face is a square of side 30 millimeters cross 30 millimeters. So with this as center, I want to construct a square whose side length is 30 millimeters cross 30 millimeters. If I do that, I will get now from the center, in order to construct the 30 mm cross 30 mm square, on the either side you offset by 1.5 boxes cross 1.5 boxes. I am drawing it to the scale of 1:2, so therefore I am choosing 3 boxes. You people should choose 1.5 boxes. So choosing 1.5 boxes up, 1.5 boxes down, 1.5 boxes towards left and 1.5 boxes towards right. You can finish it off the 30 mm plus 30 mm square by using the center O2. Completing the square by choosing 1.5 boxes on all sides. This completes the isometric projection of square of side 30 mm cross 30 mm in iso sheet, which is nothing but 3 boxes cross 3 boxes. Now through the visual inspection, dark the visible bottom face edges and also top face edges and also the longer edges. So through the visual inspection, it is clear that the top face is completely visible. So dark the top face and also the longer edges which are visible are longer edge 1, longer edge number 2 and the longer edge number 3. And in the bottom face, only these 2 edges are visible. So therefore dark only these 2 bottom face edges. Now don't show any dimensions, don't show any construction lines and also don't show any hidden or invisible lines. So therefore, if I erase them, I'll get. This completes problem number 5, in which he has asked us to draw the isometric projection of frustum of square pyramid. So this is the front view, this is the top view, and this is the isometric projection, which is drawn on isometric sheet. If I draw this in an isometric sheet, it will look like this. Now let us move on to our problem number 6. Problem number 6 states that draw the isometric projection of frustum of cone having diameters 50 mm and 30 mm with height 60 mm. So first let us draw the front view and top view so that we will get the clear picture of the frustum of the cone. If I draw front view and top view, I will get. Let me draw the horizontal line first. Now, if I look at the cone in the front view, it will look like a triangle. So therefore, the base of this triangle is 50 millimeters. So therefore, mark 50 millimeters. Since this is a cone, the bottom will be a circle of radius 25 millimeters. The frustum is obtained when the cutting plane is parallel to the base. So now when the cutting plane is parallel to the base, the top of this cone will be also a circle of diameter 30 millimeters. So therefore, choosing 15 millimeters as radius, with the same center, construct another circle. Take the projection. And mark the axis. The height of the axis is 60 millimeters. If I mark the height, I will get. Now on the either side of this axis, mark 15 millimeters. Join the longer edges, which are nothing but slant generators. Show the dimensions of front view and top view. If I show the dimensions, this completes the required front view and top view of frustum of cone. Now, in order to construct the isometric projection, as I said, apart from square and rectangle, if you want to construct a laminate, always enclose that laminate in a square or rectangle. So therefore, at the base we have a circle of diameter 50 millimeters. Construct a square around this circle. If I construct a square, I will get the square of side 50 millimeters cross 50 millimeters. Now draw the isometric projection of this square of 50 millimeters cross 50 millimeters by choosing 5 boxes cross 5 boxes in isometric sheet, and construct the circle in that square which you have constructed in isometric sheet by using 4 center method. If I do that, I will get. Select 2 lines which are inclined at 30 degrees in your iso sheet and draw 5 boxes on either side. The line should be very thin. Now draw the parallel lines. Mark the centers C2 and C1. Now draw the perpendicular bisectors from centers C2 and C1 to mark the centers C3 and C4. So choosing 2.5 boxes on all sides. Draw the perpendicular bisector from center C1. Also draw the perpendicular bisector from center C2. You get center C3 and C4. Now using compass, keeping at center C1, taking the perpendicular bisector as radius, join the perpendicular bisectors drawn by C1 using an arc. Similarly, keeping at center C2, taking the perpendicular bisector as radius, join the perpendicular bisectors drawn from center C2 using an arc. Now close these arcs from center C4 and C3. This completes the base circle of diameter 50 millimeters in the isometric projection. Now mark the axis. The height of the axis or the cone is 60 millimeters. So therefore from center O1 measure 60 millimeters, which is nothing but 6 boxes in the isometric sheet. You get center O2. Now to transfer the circle of diameter 30 millimeters, first you construct a square of side 30 millimeters, keeping O2 as center. So if I construct the grid lines, it will look like, now with this center O2, choose 1.5 boxes upward, 1.5 boxes downward, 1.5 boxes towards your left and 1.5 boxes towards your right. So if I choose that, I will get 1.5 boxes upward, 1.5 boxes downward, 1.5 boxes towards left and 1.5 boxes towards right. So this completes the square of 30 mm cross 30 mm side in the isometric projection. Now mark the centers C1, C2 and draw the perpendicular bisectors to construct the circle of diameter 30 millimeters in isometric projection. So drawing the perpendicular bisectors, initially you mark 1.5 boxes on all the sides. So drawing the perpendicular bisector, I will get the centers C3 and C4. Mark the centers C3 and C4. Now using the compass, keeping at center C1, taking the perpendicular bisector as radius, join the perpendicular bisectors drawn by C1 by constructing an arc. Similarly, from center C2, taking the perpendicular bisector as radius, construct an arc connecting the perpendicular bisectors drawn from C2. Now join these two arcs by using centers C4 and C3. Now, through visual inspection, dark the visible arcs or curves. So, top face of this frustum of the cone is completely visible. So, therefore, dark the top face completely and draw a very dark tangent to the bottom circle. So, we draw a tangent on either side. Now, from this tangent to the another tangent, you dark the visible curve. Now, erase all invisible lines, construction lines, everything to get the final isometric projection of the frustum of the cone what he has asked. If I do that, I will get. So, this is the required isometric projection of frustum of the cone what he has asked. This completes our lecture number 3, where in which we have solved problem number 5 and problem number 6 on isometric projection. That's all from this lecture.